Got an oxygen source. We can see the oxygen's coming out of here. This one has a regulator and gauge on the side of it. Okay? This is called a step-down regulator. With the big unit, the step-down regulator is over on the oxygen source tank. Okay? And this set of regulators that sit. This one, the regulator has to be here because it only has this as its source of oxygen. The pressure in here is about 300 psi. The pressure in, after it goes through this regulator, is about 40 to 50 pounds per square inch. If we had it at 300 psi, we'd have to have a much heavier device in order to deal with it. So, comes through that regulator. Here's our green hose again. Now we could take this off here and hook that up to that other oxygen source. Okay. But this makes it more portable. So the oxygen comes up, and as you can see, it's a little easier to see here. It comes up and into this bar, it goes out here, and comes in to our flow meter. Okay. Goes up through the flow meter, comes out the top, goes through this little hose, and you can wiggle it and see it comes over to here. You can see these in the simple, and that's the biggest difference. They don't close everything in a box. Goes through the vaporizer again, comes out this side of the vaporizer, and again, you wiggle the hose, you see where it goes. Goes to right there. And if you take this off, you can look in there and see that it's going to come down inside that block and come out here. So it comes out here, and we follow it on around, and lo and behold, where does it go? CO2 absorber. So now we're back in the patient circuit because we're in the CO2 absorber. So CO2 absorber, there's our little one-way valves, flutter valves, micro valves right on top. Okay. And of course, veterinarians are much brighter than the veterinary physicians and things, so they don't have to be labeled inspired and expired. You just plug that on there. And if you're interested, you can go and watch which one moves. Okay. And it's this one. So it's expired. Patient is expired up into here. Move the valve. Goes over to here, up through this, and then back into the CO2 absorber. Out of the CO2 absorber and over to here. And of course we already know where it comes in. It's over here. We have our manometer again, so we know its pressure's in the line. And we have our pop-off valve. The only thing we don't have on here is our reservoir bag because it's been taken off. So we put a bag on there. So, not quite as fancy, but the only fancy of that is the fact that they covered up all the pipes. That's all they've done. So, okay, we close the pop-off valve, and we can ventilate the patient, or we can check for leaks. See, I put my thumb over it, so now we're checking for leaks, and that's one of the things, if you've looked at that list of for the anesthetic chuck-in, you're looking for leaks. And that's all you do. Put your thumb over the end, squeeze it. If you have to keep squeezing hard, then you know you got a leak somewhere, and then you just tip down, tell everybody shut up, and you listen for it. If you're really interested, you get some toothpaste and a toothbrush, and you look for the leak. But generally, you just go and where would we suspect leaks? Patient tubing and the bag. That's where you're going to expect it. Once in a while, if the CO2 canister has been opened and new particles have been put in there, you might check to make sure that's tight. I mean, that's basically it, because if it's anywhere else, you're going to have to call me, or you're going to have to call service people. Okay. To open the vaporizer, now this doesn't push the little white button and then turn it. That's a You know, I told you physicians are not real bright, so they have to make these so that they can't accidentally open them. They have to push their finger, and then now they got to know it's open. Okay. This is in percentages, and we'll talk about what those percentages mean as we get into the inhalation anesthetic gases. You will be required to know all of these parts that I've gone through. What's in the circuit, what's out of the circuit. I want you to, not for exams, but for your own knowledge, to be able to trace the flow of the oxygen and the gases through a machine. And the reason is, if you have a problem during a procedure, I want you to be able to solve